Hello and welcome. Today is February 5th, 2026, and we are playing Pips, easy, medium, and hard. So starting with the easy one, I don't see any double tiles, so we cannot have a double here. So it must be like this. Um, then, well, less than two, we have a couple ones and a couple zeros. But what we have three of, just the fives, right? So I need to put a one and five here. Then and for this be to add up to five, um, we need five, five could be five and two, and then three and zero, 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 one, five, four. Yeah, that works. That works. That there could be another solution, but there's no reason to look for it since this works. And it took me long enough. Long enough. So let's go to medium. Oh, nice. It's cross, kind of cross, like um, disassembled cube, something like that. Okay, we have a 10 here, and a 10 can be 5 and 5 or 6 and 4, but we only have one 5, so it needs to be 6 and 4. We have 4 and 2, we have 6 and 2, and we have 6 and 4. So all of those three tiles are options for this. Then we have, okay, here we have 4, 3, and an equivalence. We don't have a 4 and 3, so we have 3 and 2, and we have 3 and 5, but we don't have 4 and 5, so we need the 3 and 2 to be here. Oh, come on. And then 4 and 2. Okay, that's one last option for us here. Actually, there's only one 4 left. And, well, it could be, it could have it like this and then another 2, or we could have um, this and then a 6 and 2. We don't know yet. We don't know. Because we need one of the 2's here. And it needs to add up to 7 here. So it could be 2 and 1. Could be 2 and 5. Could be a lot of things. Now to make 8, we could have 6 and 2 or 5 and 3. Let's try this. Just let's go with the simple. And then this will be 2 and 1 up there. Yeah, this works. This works. Um, and this could we could go two ways. We could go with the 4 and 6 like this, or the other way with the 6 pointing up. We just need the 2 to be on the 2 square. Okay, let's play hard. Okay, one donut and one square. Okay, this we have a region that adds up to 18, and so we need this double 6 to be there. Do we have any other doubles? We have ones and threes. So it could be, and then a 5-0, and then well, the other six is with a 0, so it needs to be this way. Then 6-0, then could be 0, cannot be 0-5, could be 0-4. No, oh yeah, could be 0-4 and 1-5. Can it be 0-3? Then I would need 2 and 5. Yeah, could be any of these two options, either 0-4 or 0-3. So let's take a look at the square here. We have five equivalence regions, one of them with 4 squares. And we need a 5 here, which cannot be the 5-0. And it can be the 5-2 if it points right. And then 2-4 and 4, or cannot be 4, it cannot be 4-0. So um, the only, well, okay, yeah, we have doubles. The only way for us to use 5-2 here would be if the 5-2 points right, because we don't have 3 2's. But if we do 5-2 here, then we need 2-4 here. I mean, we have several 4's actually. Then this would have to be a 4. Can be a 4-5 pointing left. No, it cannot be, because we would need a 5 and 5. Also cannot be a 4-5 pointing down, because we don't have enough 5's. We would have only 3 5's left, not 4. Um, could it be, cannot be a 5-0, because we know we need a 0 here, so we don't have 3 zeros, and much less 4 zeros. Can it be 4-3? Could be 4-3, yeah. Could be a 4-3 and then 3-3, or even pointing down 4-3, 3-3, and 3-0. Now this 10 can be, it needs to be 2 5's. Don't have any 6 left. And we have, well, it depends on what we are going to put here. So let's go back to this 5 here. What do we have 4 of? I think only we have uh, 4 5's, but we need 1 5 here and 2 here. So we cannot have 5's in this equivalence region. We only have 3 1's and 2 2's. We have 4 4's. But we know, no, we don't know anything. We can use 0, 3, and 2, 5, right? Which I'm not convinced about that, but we could we could have 4's here. We could have 4's. 4, it would be 4 and probably 3 pointing up. 4 Could be 4, 2, 2, 5. Then no, but then we would need either a double 4 here or yeah, we would need a double 4 because otherwise we cannot have two tiles with the same values. We cannot have 4, 3 and then 4, 3 again. And this would have to point right, so 4, 4. Or this could point up and this could point any other direction, but then here we would need a 4, 4. So this cannot be 4. This needs to be 3. Um, this needs to be 3. So if it needs to be 3 and we have 4 threes, it means we cannot not have the 3 here, so we must be the 4. Must we use the 4 here and then 1, 5. Then can we have 5, 0 here? Well, this cannot point left nor down because we have 5, 0 and 5, 2, but we don't have 3 of them. Neither 3 zeros nor 3 twos. So it needs to point right. And we checked that um, we can do it with 5, 2, right? 5, 2, 2, 4, and 4, um, 3, um, either to the left or down. Can we do it with a 5, 0, 5, 0, 0, 3, 3? No, because the 3 needs to be down here. We established that already. So it needs to be 5, 2 here, then 2, 4. Then could be, well, the other two 5s need to be here. So how do we do that? Because we don't have 5 and 5. Oh, shoot. We don't have a 5 and 5, 5 and 5 tile. So we would need 5, 0 and 5, 4. Because we don't have 5, 3 and 5, 1. Um, wouldn't, we don't have enough ones, we don't have enough twos. So it needs to be, well, hmm, I'm confused. What if I take this out and put it this other way? Then this doesn't work. Oh, wait, we can use the 5, 4. I don't know why I said that. I don't know why I didn't consider this. We have enough force to do that. And then 5, 2 can go here. Then this needs to be 1 and 1. But we don't have 2. We have 2 and 4. Okay, this works. This tracks. 4 and 3. 0, 3 and 3, 3. Okay, we got it. Wow, 9 minutes. All right, um, that's done. Thanks for watching. See you tomorrow.